Welcome. I'm so glad you're here. Welcome to this week's webinar. And if you're a regular webinar attendee, then you've heard this before, but we have so many new folks tuning in to the webinars on a weekly basis that I just want to frame what we're talking about here, and then we'll jump into the topic. Your time is valuable, and we'll get this this topic talked about and get all the high points, and then I always welcome emails for follow-up. But um, if you're signing up for these types of webinars and you're searching out this type of information, then that means that you want to get more done, you want to move faster, you want to produce higher quality, and you want to deliver for your team and for your company and for your customers. So this series that we're doing, this 7-week series, is .NET DevOps for Architects. It is guidance aimed at software leaders who want to enable their teams to be world-class. And I know from experience that if you map out your software delivery process and automate it, you will deliver more. And you and your team will absolutely love programming and love software delivery. But we do have an enormous problem, and a problem that we're going to have to solve. Most teams automate the work for their customers, their own customers, by producing software, but then saddle themselves with manual processes and new administrative work to build and deploy and monitor software that relieve the customers of their administrative work. And there's no reason that the cobbler's kids shouldn't have shoes. And so I work with all the time with teams where one of their most senior, most capable developers is trapped by the task of deploying the software because he's the one who understands the software the best. So they take their best talent with the most experience with the software and reduce him to weeks full of administrative tasks. A deployment is a set of administrative tasks. You copy files, you change a config file, configure a credential, start a service, but then you do it again and again and again, over and over and over. And we all got into software because we saw the tremendous power available to us. We can write code and make the computer do something that makes ours and other lives better. And so then we shouldn't settle for a manual, error-prone, slow process of managing and deploying our software. So whether you're an individual developer, whether you lead a team, or you're a manager in technology, this webinar series is for you. And last week we had an overview of the continuous integration build. And next we'll go through the common mistakes and the 3 critical elements of release management. Okay. Finally, I'll show you how to get started. Now, I have a free offer. I want to give you something of value and help you get automated. I don't want you to continue to be frustrated and sometimes trapped by the software that you work on that seems to always find a way to break when you deploy it. And I do understand the lost weekends and sometimes surprise overtime due to software builds and deployments going poorly and business disruptions. So at ClearMeasure, we have helped thousands of professionals across over 40 countries be better at software. And my latest book, .NET DevOps for Azure, exposes the secret about how any team can have a fully automated DevOps pipeline by following a concrete 7-stage design. And I firmly believe every single development team can be world-class when equipped with the right process, the right skills and tools. So here's what you need to do. First, read my book, and I'll give you a free ebook copy just for being here today on this webinar. Send me an email or post in the chat or the Q&A window, and I'll get it to you. And whether you're watching live or if you catch the recording, send me an email. I'll be happy to get it to you. Step 2, read the book and understand the 7 stages of a DevOps pipeline that's in the book. And then thirdly, launch your own .NET DevOps pipeline and use our public project as a model, and you'll find it in the book. And if you do this, you'll have a fully automated DevOps pipeline using Azure, and that'll enable you to move faster and with higher quality. Also, week after next, time is running out. Week after next, I personally am teaching a 2-day in-person, immersive, hands-on boot camp. It's .NET DevOps boot camp we have just a couple of seats still available that we can squeeze in. So go to that URL bit.ly/.NET DevOps Bootcamp. If you have any questions, just send me an email. And I'm teaching that training class in Austin, Texas. Also, make sure to subscribe to the Azure DevOps Podcast. You can go to www.azuredevops.show or search for it in any of the podcast directories. So where we are in this webinar series, we are covering full system testing and user experience testing. This is the release management umbrella, okay? And these are the two items that we're going to cover because we're just starting to deploy a build. And so we need to figure out how to deploy to our first line test-driven development environment and do full system testing, and then get that merged into master and pushed out to a manual test environment so that we can have the appropriate people do user experience testing. We're going to touch on that in a light way, heavier today on full system testing. All right. So common mistakes that happen all the time. First, lack of a release candidate. So every build tool allows you to store build artifacts, and build artifacts can be essentially a folder dump of what was produced from the compilation process. And then we leave it to the activity of the environment setup and deployment to get the right parts in the right places. So we need an actual release candidate, but think about this, the mental model. A release candidate is a build that is a candidate for release to production. But there's multiple things we need to do before it can get to production. So a release candidate should have a name and a number. Now, often multiple deployed processes are part of a single release candidate. For example, our simple application architecture of a web application, an offline job, a SQL database, and a test suite. We have multiple things we need to deploy, but together that represents a particular release candidate. And you want to use Azure artifacts, whether you use NuGet packages or universal packages. Azure artifacts was built for this. Secondly, a second common mistake is a slow feedback cycle. And this can be created by the lack of environments as well. 2 environment types are really necessary to get to the point where we can say that we have a release candidate that's ready for a production deployment. Okay, those 2 environment types are the manual test environment and the automated test environment. Okay, production is the third environment type. And those are the 3 types of environments. You need at least one of each in your pipeline: your production environment, your manual test environment, and your automated test environment. We call the automated test environment TDD, to invoke the test-driven development name. We typically call the manual test environment, or the first manual test environment, UAT, user acceptance testing, because everybody needs to have a user or a product manager, a candidate user, look at it and say, you know what, this is going to work for our actual production users. And you can have as many manual test environments as you want. Common names that we see are dev, development, test, QA, staging. There's all kinds of names for a manual test environment. And you could have 17 manual test environments if you need, but you need at least one. Okay. So in our sample, we have one of each, and you can have as many of each. You can have them in parallel, you can have them in sequence. That's up to you, but you need at least one of each. And so when we're talking about a slow feedback cycle, the lack of the appropriate environments can slow us down because we have environment contention. And we'll talk about that in a little bit. Third, relying on users or stakeholders for testing is a mistake. We've all seen where we say, hey, a new build is ready for testing. And then you have your stakeholders kind of pull it up and it just blows up in their face because something was broken and that was the first time it was deployed and started up. We've all seen that in a new release candidate, but that's not what we're talking about. Now, that does slow you down, and you don't want to do that because now you've wasted how much time just to figure out that you had a bad build. That should never happen, and I'm going to give you the tools here in this webinar to squeeze that possibility out in your environment. We want to do automated post-deployment functional testing before we ask a user or a stakeholder to even look at it. And we'll dig into that later. Stakeholders, from a mindset, stakeholders are thinking at a higher level. They aren't thinking, hey, perhaps this new release candidate has a new thing broken that wasn't broken last week. They're not thinking that. They're evaluating the new changes. They're thinking, is this going to be easy to use? Is this how I thought it would come out? They're really applying their critical thinking. They're not inspecting the team's work. They're not inspecting, did the team accidentally break something that has been working for a long time? Okay. Now, dedicated manual testers, they do. And I've worked with some really great full-time testers who are really organized and comb through every time. But as we've seen in the industry, even if we do have a team of those types of people manually combing through every build process, we have a slow feedback cycle if we don't automate most of the functional testing. Okay, it's just a reality. Now, this is the Onion DevOps model, and again, some of you are already familiar with it. And this is just a quick review. We have multiple nested cycles. The inner cycles spin faster than the outer cycles, and obviously, you're going to have multiple code commits. Lots and lots of code commits for every one release to your actual customer. So the customer release cycle, the customer cycle on the outside, that moves slower than the product cycle, which is your rate at deploying to manual test environments to whatever your product team is in your company. And then the team cycle is the rate at which pull requests are reviewed by team members and absorbed into the team's master branch. And then the code cycle is individual workstations, private builds, the test-driven development cycle, things that are happening on a feature branch. And so we have concentric circles representing the different cycles in DevOps, and the inner cycles they must spin faster than the outer cycles. However, the cycle differentiator determines overall team productivity. For instance, if going from we have a new build on the master branch and the team says it's ready to go to when we can actually have it deployed to our product team or deployed to a manual test environment, if we have to wait a week on some outside party that has to do our deployments for us, then that cycle time is really low. Or if we're changing a configuration on the environment and that takes us a long time, that slows down our cycle time. We want to be able to say, hey, it's ready. Hey, product team, you ready for the new build? They say yes. Boom, 10 minutes later, they've got it. We want that differential in the load for our cycle time. All right. Now, this is the process flow, and you see the yellow lightning bolts are the elements that we're touching on today. Okay. We talked about the continuous integration build and the packaging mechanism last week when we talked about continuous integration. If you missed it, just get with us, and I'm sure we can get you the recording or put a note in the chat or the Q&A window, and Rain can get you hooked up with the recording. We talked about how to package last week. Azure Artifacts is where we put those release candidate packages, and now we are going to deploy them to our TDD environment and run full system tests, and then we are going to deploy them to our manual test environment, okay? Those three steps, that's what we're focusing on this week. Now, just to review a bit, these are the things that we're looking at in the code cycle. We're asking questions, did my test pass? Does it work on my box? But we're also asking, does it deploy? Did it deploy and pass our full system tests? Is it done? Is it ready for a pull request? Okay, that is huge. Now, to back off a little bit and look at the team cycle, the types of questions that we as a development team are looking at is, does all existing functionality still work, or did we just break something? Right? That's the automated regression. We can't afford anymore to do manual regression testing. We're obviously putting new features, new capabilities in, and we have a master branch that produces release candidates that have a potential to get all the way to production, whereas the beta release branches that are produced, release candidates that are produced by our feature branches, those will never go to production. They're beta. But we do a pull request, we merge into master. Those release candidates have a potential if they're good enough. but we need to know the answer at the team level. Does all existing functionality still work, or did what we just merged into master accidentally break something that was working? We need to know that answer. If not, our cycle time will be slow because those things will slip through. Okay. And the cycle above it, the product cycle, where we're doing manual testing, those questions on the right-hand side, does it work properly on the different computing devices? Can I sell it as it is? Is it ready to go? Notice the questions not being asked there is, did something old just break? Okay, we need to find that at the team level, not with stakeholders or real or surrogate users. Okay, so let's keep moving along. The three essentials to release management. Each release candidate is set up in a handful of files. And if your application consists of a web application, an offline job, a SQL database, then you'll have 4 files that make up the release candidate, one for each deployable component of the application. Your full system test is your 4th file, your 4th release candidate component. Now, let's talk about short cycle times again before coming back to testing. Environment contention really slows down a team. I hinted on that. Even if you don't have elastic infrastructure and you can't create a server on demand, there are techniques to be able to have multiple release candidates fully deployed and running, sharing the same operating system. So you can parallelize and multiplex environments. One common technique for a Windows service, for example, is to deploy them with a name that embeds the environment and release candidate number. So instead of having Windows service called My Service, you would have My Service TDD v-3.24.460. And now that's unique. And you can have as many of those Windows services as you need, so you don't have that contention. Multiple instances are running. They can share a single server. And all of those are low volume at the functional level, so you're not worried about exhausting computing resources. But move globally named resources to naming them by environment and version. And you have to find some way to, quote, create as many environments as possible so that you never have to wait to move a new release candidate down the pipeline. We need to eliminate waiting. Now, post-deployment testing, I'm going to come back to that in a minute, but I want to talk about the process. It's very important to have formal release candidates. These candidates are created once, they're deployed multiple times, and when some feedback is recorded, there's a unique version number. Here is the mapping of our application components to the NuGet packages that, notice they have all of the same version number. They are named according to the component of the application, and they make up a single release candidate, and they are 4 files. All right. Now, on the mapping, these are the 4 files that we show, and 3.4.352, that's our release candidate, and they're stored in Azure Artifacts. Now, let's look at the team DevOps cycle. This starts with defining done, air quotes done, which it'll be familiar to the Scrum folks out there. Test design is deciding how a feature will be tested, what the steps are, what failure cases we're designing for from the start. Bullet points, use bullet points. The simpler, the better. And we program the feature and the test together. That's test-driven development. Then when we finish programming and have submitted a pull request, the card is in the 3rd column, and it's normal to decompose a feature into codable parts, but to get it to a user or stakeholders, we have to give them a release candidate that has the new feature working. There's no way that they could test just the data access layer or some other incomplete layer, even if it did make sense for us to sequence development of that feature in that manner and break it up in that manner. This on the screen here is a full team DevOps cycle in an activity diagram. You can see the last step is inspection. This is best implemented by a pull request. Capers-Jones is probably the best at aggregating all of the available industry research that we have in the software world on quality. And there's 3 quality control techniques that when put together reliably yield really, really good defect detection and defect prevention in a process. And those 3 are testing, which in Onion DevOps, you have a minimum of 3 levels of automated test suites, and you have user acceptance testing. So testing is one. Static code analysis is another. We talked about that in the continuous integration build week. And then the third is formal inspections. Now, we've all heard of code reviews. A lot of you are using pull requests, but the pull request process is the best place to implement a formal inspection. And how you can do that is, as a team, decide on an inspection checklist of everything that is going to be checked on every pull request and record the results of that inspection and reject the pull request or don't approve the pull request until all of those inspection criteria are satisfied. And that is a great yet simple implementation of a formal inspection. And by the way, you're recording it so it can be audited later on. Now, notice that we need here in our process to traverse 4 different environment layers to execute our team DevOps cycle, our team loop. And automated acceptance tests are part of this. Post-deployment full system tests, that's what they are. And yes, let me drive that home. That means we need to make sure that our change deploys, starts up, and doesn't break anything new before we submit a pull request. This is a big idea, folks, and a huge differentiator in both quality and speed from a process that entertains pull requests not knowing if the change will even deploy and start up properly. That doesn't work. You can't approve a pull request if you have no idea if the application will even start up, much less knowing if something else was accidentally broken. We need that answer, and it's not hard to get. All right, so here's an overview of our pipeline. Just to ground, we have at least 1 instance of every unique environment type, and our team cycle doesn't go past TDD. Remember, we're using feature branches, and so the feature branch will have a build run on it, create a beta release candidate that'll be deployed to an instance of the TDD environment. Full system tests will run against it, and then we're done with the pipeline for that feature branch. When it goes to master and we have a build that produces a release candidate, a real release candidate, it'll go through all the environments, okay? And so as we run our full system tests, we capture those test results running against the TDD environment. And it's a really good idea in the web application standpoint. We're running in a browser, we're running with Selenium, we're clicking on buttons, we're typing in text boxes. And it's a really good idea to implement screenshots or screen grabs while those full system tests are running so that you can see what the screens look like and ward off any problems, especially when a test fails, you'll see exactly what the screen looked like, okay? And so if we zoom in, we can see on the right, we can see a form. We can see some text boxes that were typed in. We can see a button that is clicked. And then on the left-hand side of the screen, we see 3 different screenshots that were taken while this particular test was running. Okay, so it's important to integrate screenshots when you have an application with a user interface that you're doing full system testing on. And then our pipeline, when it runs, we can see that 100% of our tests succeeded on the TDD environment. And of course, on a master branch, it goes down. We don't run automated tests on UAT. And then we block at production with a manual approval step so that one of our stakeholders can hit the approve button. But you see, we have tests that run post-deployment on the TDD environment. And that makes no difference if you're actually deploying to Azure PaaS services with Azure pipelines, or if the stage is delegating to Octopus Deploy and you have a very complex deployment process going on there, then the control returns from Octopus Deploy to Azure Pipelines, and Azure Pipelines runs the test suite. All the configurations, it's the same. You want post-deployment test automation running at that TDD environment stage, okay? Now, for user experience testing, we continue the pipeline once the pull request has been merged into master, and we deploy to the UAT environment, which that can be multiplexed as well if we need to. And it can be a good idea to use recorded testing sessions to help users remember what they were testing when they encounter a problem. And just a hint, check out Azure test plans for that, and check out the Chrome browser test recorder extension from Azure DevOps, which can make that seamless, and users can just click, hey, record, and it'll even turn on their microphone if they configure it so that they can narrate what they're doing. All right, so the 3 essentials, just to review, each release candidate has to be a formal release candidate. We need automated post-deployment testing, and we need to make sure that our pre-production deployment cycle is as short as possible. And I've given you techniques to do that. All right. Now, we've just covered the beginning of release management, full system testing, user experience testing, and that element. And next week, we are going to cover the rest of deployment, the actual mechanics of deployment, what your options are, and that'll get us to production. But I wanted to really stress the full system testing aspect of this. Obviously, it does rely on deployment logic. And so next week is going to be all about the automated deployment and the mechanics that we use in order to make a deployment automated, and not have to rely on manual steps. And this is going to also include automated environment provisioning, because if we have a pet environment, and I see it all the time, people go into the Azure portal and they use their mouse, or they off the top of their head, you even use command line, the Azure shell, and they create resources, and then those resources, Azure resources, are computing environments, whether they're a VM or Azure website or Azure SQL, they're there and they created them. And now they set up an automated deployment to them. But guess what? They're the only ones who remember exactly how they configured it. And the configuration and provisioning of it was not captured in any source control repository where it could be run again. So when the environment needs to be modified, guess what? They have to go and do it manually. Or if the environment needs to be re-provisioned, guess what? They have to remember how they did it. And so we're in the exact same situation as if we're managing physical servers in a data center or with VMs. So next week is super important. We're going to cover all of deployment, which means creating the environments, the computing environments from stuff that's in a Git repository, and then deploying to those environments using logic and scripts that's in a Git repository. That way you're completely and you're fully versioned. So don't miss next week. That's what we're going to cover. Now, next steps, remember, send me an email so I can send you a free copy of my book. And as you read the book, use the included Azure DevOps Services project template and literally get up and running within a day or less than a day. And at the end of this webinar series is a special surprise. I am going to provide you with a template that can get this complete environment up and running. And I think that I'm going to be able to do it for you in about 20 minutes. And it's a fully automated routine. We're just finishing the development of getting all those things in place. So stay tuned, tell your colleagues. Also be sure to subscribe to my podcast, the Azure DevOps Podcast. And next week, tune in as we dive into how to provision infrastructure and deploy. And remember, this is absolute truth. You, your colleagues, your team, every development team is a world-class development team, moving fast, building smart, running the systems with confidence when equipped properly with the right process, skills, and tools. And so you can do it. I believe in you, and I want to give you the tools to do that. So send me an email with any questions. You can find me on Twitter at Jeffrey Palermo. And remember, make sure to get my book. Get the ebook offer now, November 2nd. It'll be available on Amazon. It's available for pre-order now, but it's going out from A-Press. And get the DevOps template, get automated for yourself, lift and shift your legacy applications into a world-class DevOps structure, and jumpstart your new applications using this template. You could spend weeks on it. Just use the template and then modify what needs to be different for you. So thank you so much for your time this week. I got you in and out in 32 minutes this time. That's awesome. 'cause I know your time is valuable, and keep shipping.